Meet Susan. Susan is a 23-year-old computer science student at the university. Today she has a semantics lecture which she is really excited about. Susan likes to get to the bottom of things, to reach understanding. She often reflects on possibilities, implications, applications, and consequences of what she's learning. Susan is characterized by a preference for deep learning. She spontaneously uses higher cognitive processes. Faced with a curriculum, she basically teaches herself. In fact, we almost cannot prevent her from learning. But she is not our concern today. Robert, on the other hand, is. Now, where is Robert? Ah, there he is. Robert is also a Homo sapiens, same age, also a student of computer science, and also has the semantics lecture today. However, Robert is a different type of student. His goal is not to achieve understanding. In fact, Robert doesn't really care about the learning in itself. His goal at university is different. His goal is to get a piece of paper and a handshake from an important man with gray hair, to pass exams, get a degree, and get a decent job. Robert is characterized by a preference for surface learning. He will only use higher cognitive processes if he really has to. He will cut any corner in achieving his goal with minimum effort.
So I'm sure that you can all see that the familiar structure of a finite automaton can easily be interpreted as a labeled transition system where the configuration simply will be the states of the automaton.
Let's have a look inside the auditorium to see how Susan and Robert are doing.
Arrow, the transition relation, will
Let's look a little closer.
Of the automaton.
This is interesting.
A bisimulation between two concurrent systems is a relation on the states, satisfying that for any two related states, if one system can perform an A action,
now let's have a look at Robert.
In such a way that the two systems end up
what is the break?
States belonging to the bisimulation. And we say that two systems are bisimilar if and only if there exists a bisimulation between the two systems. I just give you one example. If you think of a programming...
Here you might think that Robert is the only one to blame, that he's the only one responsible for his mediocre gain from the teaching. But Robert just has a different goal than Susan. He's merely responding to a system. The statistics also carry an important message and suggest a different course of action. 20 or 30 years ago, there were mostly Susans at the universities. Nowadays, however, as student intake has increased dramatically, the Roberts now outnumber the Susans. This makes for a considerable problem which is important to tackle for any responsible modern society. But before we deal with it, Robert's learning that is, we need to take a look at the situation from a different perspective. Let's see what the teachers have to say about our two students.
Yes?
Excuse me. Could you tell me about Susan, please?
Susan. Yes, Susan is one of our good students. She always does well, not only in my own classes, but I know that she performs well in all classes. She's truly one of our good students.
Then what about Robert?
Robert.
You know, the guy...
Ah, Robert. Well, he's one of our bad students.
Notice how this labeling conveniently defers responsibility. In particular, we cannot do anything about it. It's just the way students are. Either good or bad. This good student, bad student perspective is also known as the blame the students approach to teaching, and is level 1 in John Biggs' 3 levels of thinking about teaching. A level 1 teacher is concerned with what students are. For him, the exam is a matter of sorting the good students from the bad. A level 2 teacher has the focus on the teacher and is concerned with what the teacher does. From this perspective, there are good teachers.
I made an animation yesterday, and you'll see the information in blue coming up here.
Bad teachers.
For the proof of lemma 37b, assuming that proposition 21g holds.
This perspective is also known as the blame the teacher's perspective. A so-called good level 2 teacher will attempt to arm himself with an armada of teaching techniques, tips, and tricks. There are many types of level 2 teachers. However, common for most of these, apart from having a teacher focus, is that the result is passive students. We need to engage and activate the student.
And then she said, it was the transition system.
Great teacher. Man, that guy was good.
Yeah, but I didn't really get the point about the indexes, and I wasn't too sure about the rest either, but yeah, great teacher.
As clearly demonstrated by our entertainer teacher, activation itself is not enough. A teacher at the most advanced level, level 3, is particularly concerned with what a student does before, during, and after teaching. That is, he is particularly concerned with the product or the learning outcome of the teaching. But before we can go there, we need to understand understanding. Since we were talking about activation, I'd like to activate you, the viewer, using the following puzzle. Please consider the following numeric transcription system, where 1 is written like this, 2 like this, and so forth. I'll give you 10 seconds. Now I'd like you to write down, say, the last 5 digits of my office phone number, 18725, in this numeric system.
We, Homo sapiens, are quite bad at memorizing random information. Psychologists claim that we are only able to hold 7 plus minus 2 pieces of random information in our short-term memory.
Now, suppose I showed you the following grid. As you can see in this number system, 1 is at the top left corner, and hence written like this, whereas, for example, 8 is at the bottom, and hence written like this. Now you can probably write anything using this silly number system for the next 65 years.
The point is that we as humans learn by associating new and unknown information with old and known information, or that we build new information on top of old information. In this case, it was easy. We simply exploited that you all knew a certain geometric shape, the grid symbol, and the numeric layout of a conventional telephone. But when teaching semantics or fertilization or political power theory or Roman literature, it may not be clear what the students know or how they know it.
The point is that knowledge is constructed as a result of the learner's activity. This is in sharp contrast to the old, now abandoned idea that knowledge is transmitted from a teacher to a passive learner. Transmission is not the way humans learn.
And we say that two systems are bisimilar if and only if there exists.
Active knowledge construction is. Learning takes place through the active behavior of the student. It is what he does that he learns, not what the teacher does. However, activation itself is not enough. We also need a theory of understanding to take into consideration how students are activated. Professor John Biggs has such a theory. The solo taxonomy, short for structure of the observed learning outcome, distinguishes 5 levels according to the cognitive processes required to obtain them. The lowest level in the taxonomy, level 1, is known as the prestructural level, at which the student has no understanding, uses irrelevant information, and or misses the point altogether.
One final question. What is a cow?
Level 2 is known as the unistructural level, where a student will focus on one relevant aspect only. Here the student has the competence to identify, to do a procedure, and or to recite.
A cow is when you're milking.
A student at the multistructural level, level 3, can focus on several relevant aspects, but they are considered independently. He is able to classify, to combine, to enumerate, and so on.
Cows give us milk, and when slaughtered they give us oil, meat, fat, bone, and leather.
At level 4, which is called the relational level, a student can now link and integrate several parts into a coherent whole. Details are linked to conclusion, and its meaning is understood. He has the ability to relate, to compare, to analyze, and so on.
The essential difference between a Jersey cow and a Hereford Angus cow is that a Jersey cow produces a lot more milk, but is substantially smaller.
At the 5th and highest level, the extended abstract level, a student has the capacity to generalize the structure beyond the information given, and even produce new hypotheses or theories which may then be scrutinized.
Cattle, or kai, are domesticated ungulates, a member of the subfamily Bovinae. And it seems to me that humans must have been the root cause for the diversification of cattle, because they were selected for different genetic characteristics like draft, milk, meat, size, color, and behavior, to name a few.
We refer to levels 4 and 5 as deep understanding.
For instance, one can prove that it is always an equivalence relation. Yep.
Excuse me, isn't this the same as last week, except with implicit environment?
Levels 2 and 3 are referred to as surface understanding.
We could have composition, the usual semicolon operator, and then we'll have an if-then-else construct, and...
Wait, is that a colon or a semicolon?
In this particular course, we...
So the million-dollar question is, how do we get students to learn what we want them to? More precisely, how do we get a student's activity to match our intention as a teacher?
The answer is constructive alignment. That is, to clearly state the learning objectives of the course in terms of the solar taxonomy, to make the exam measure precisely those and tell this to the students, and to choose appropriate teaching learning activities to train these skills and competences during the course.
The constructive alignment theory was developed by Professor John Biggs. Let's first have a look at an unaligned course. We have the teacher's intention, the student's activity, and the exam's assessment in play. The teacher has an intention. Let's suppose he wants the students to be able to explain, relate, prove, and apply. And now suppose the exam measures something else. For example, the ability to memorize and to describe. In this case, Robert will focus only on the skills required for the test, disregarding the teacher's intentions. This is called dealing with the test.
Of course, you can extend with as many operations as you like.
So, do we have to know about this for the exam? Okay, here's the thing. I know what they're asking, but I figure, and Jim also told me, that if I memorize the headlines and skip through the first chapters, I should be okay for the exam.
Now let's have a look at an aligned course. Here the teacher has taken great care in making the exam explicitly conform to his intentions, so that the exam now measures the ability to explain, relate, prove, and apply. Here there is no shortcut for Robert. Whatever happens, he just ends up learning what the teacher is intending.
So these are the course objectives, and also what you'll be expected to be able to do at the exam, and what my exam will measure. Furthermore, this is what we're going to reflect upon during the course, and what you'll be trained in doing during the entire course.
A Level 3 teacher has a student learning focus. This is the highest level in John Bigg's 3 levels of thinking about teaching.
So now I'd like to give you 3 minutes to prepare an argument for why this aspect is syntactic and not semantic.
Now we are in a position to actually define good teaching.
Exactly, yes.
Good teaching is getting most students to use the higher level cognitive processes that the more academic students use spontaneously. Or you might say, teach so that Robert behaves like Susan.
Which is just one shorter than E.
Yeah, and then we prove it holds. Yes, that's how we do it.
You did.